This trainer demonstrates vehicle front and rear lighting systems, together with warning signals such as turn indicators and position lights. Let's go through all the trainer's components. The stand is powered by a 12-volt external battery, or an alternative 12-volt power source can be used. Here we can see the fog lights at the bottom, the main front headlights, and the rear vehicle lights. It is also equipped with a front wiper motor. The lights are mounted in the same way as in a real car. The left side and the right side are arranged exactly as they would be in an actual vehicle. Next, the stand features a central brake light. Above, you can see the light and rain sensor, number plate illumination lamps. On the outside, the onboard supply control unit is installed. Below it, the trailer detector control unit. Here we also have a safety stop switch. Control LED indicators. PWR indicates power supply, and ON shows whether the training stand is enabled. Below, there is the ignition switch. Additional 12-volt terminals from the battery are available for extra measurements if required. Here we have the fuse block, the OBD diagnostic connector, and a 13-pin trailer socket. Next are the switches for the reverse lights and the brake lights, and the hazard warning light switch. On the steering column, you can find the control stalks, light switch, turn indicator switch, and wiper control switch. Below that, the instrument panel illumination dimmer and the headlamp height adjustment controller are installed. Here you can also see the data bus diagnostic interface, the main light switch, and the instrument cluster. In the center, there is the electrical circuit diagram with open contacts and jumpers for measurements, along with a legend showing all symbols and values. This training stand is unique because it includes a built-in fault simulation module, which allows up to 10 different faults to be simulated. This feature is available as an optional add-on and is not included in the standard equipment configuration. How this educational trainer works. We start the trainer using the ignition key, and the LED indicator shows ON. Next, we switch the light control switch to the auto position. In auto mode, the lights are controlled automatically through the light sensor. When it is bright, the headlights remain off. When it gets dark, or if we cover the sensor, the lights turn on. The rear position lights also switch on automatically when it becomes dark, or when we simulate darkness. The headlights are directed toward the wall to replicate how lights are positioned in a real car. This also allows us to see the light beam directly in front, which is useful when practicing headlight height adjustment or changing light intensity. Now, by using an external incandescent lamp, we can simulate changes in brightness at the light sensor. This imitates changes in outdoor lighting conditions, demonstrating how the automatic light sensor works and why the headlights turn off when they are no longer needed. Next, we switch the lights to the main continuous beam. Here we can clearly see the light beam and closely observe how the headlamp looks when illuminated. We also check the front and rear fog lights, which are activated by pulling the light control switch towards yourself. Using the original stalks on the steering column, we turn on the turn signals. The indicators function correctly in both the front and rear lights. We can also activate the hazard warning lights. With the additional buttons, we can switch on the brake lights. And with another button, we can activate the reverse light. The stand includes a 13-pin trailer socket, which can be tested using a special signal testing tool. After turning on any lights, the tester's indicators show whether the signal is functioning correctly. We can also test the operation of the front windshield wipers. The wipers are controlled using the original lever on the steering column. By pressing the lever down once, the wiper performs a single wipe cycle. Lifting the lever one step upward activates the automatic wiping function. We can simulate rainfall by applying some water to the rain sensor. The wiper will start operating automatically once the sensor detects moisture. Lifting the lever further engages continuous wiping, and then the high-speed wiping mode. This allows us to observe how the wiper speed changes depending on the selected function, just like in a real vehicle. A practical exercise example, measuring the voltage of the number plate lights. Using a multimeter, we locate the number plate light circuit on the electrical diagram. Connect the positive multimeter lead to the number plate light terminal and the negative lead to the common ground socket. After switching on the number plate illumination, we measure a 12-volt signal. The same procedure can be performed for all other components on the training stand. This helps learners understand electrical operation principles and practice fault diagnostics in a hands-on way. Let's look at another practical exercise example, performing an output test of various components using diagnostic tools. First, we connect the diagnostic device to the OBD connector on the training stand. In this example, we are using the VCDS diagnostic tool. In the diagnostic software, we select Output Test, and then choose the components we want to check, for example, the brake lights. After pressing Start, we can see that all the brake lights illuminate. This is an excellent way to learn how to test individual vehicle components using diagnostic equipment. Let's try another one. We select the right turn indicator. During the test, we can clearly see that it operates correctly. Next, we test the front wiper motor. In the system, we select the wiper motor for testing and start the test. The wiper motor runs smoothly, demonstrating proper operation. We can also test the components of the instrument cluster. Let's select the tachometer. After starting the test, we can see the tachometer needle moving as expected. The test is successful. Now let's test the fuel gauge. The needle rises, falls, and returns to the halfway position, confirming that this component is also functioning properly. Another practical exercise example, measuring the CAN signal using an oscilloscope. First, we connect the oscilloscope probes to the CAN signal output, indicated on the electrical diagram. In this case, we can observe how data is transmitted between the J527 and J533 control units. The oscilloscope display shows that the signal between these two units is present and that communication is stable without any interruptions. The lighting educational trainer provides a complete and hands-on way to study vehicle lighting and signaling systems. It allows learners to explore real electrical components, perform diagnostic tests, measure signals, and understand system communication through practical exercises. This trainer is an effective and safe solution for mastering automotive lighting system principles and diagnostics.